Another important concept from lesson 3.2 is the empirical rule and how standard deviations are applied to the world and how we make decisions or come up with some answers to things about the population of interest. And so on this problem here, looking at 3.231, you're given some information about, you have some data. It's bell-shaped, so it has a normal distribution or again, symmetric distribution. We know what the average from the population is. It's 330, and the standard deviation is 45 grams. And so with that type of information, the weight, this weight information, we can then determine the percentage of, in this case, organs of adult males that weigh between a certain amount of values without even knowing what the, without even having the data in front of us. We can answer these questions as long as we know that the information is bell-shaped distribution or normal distribution. And again, that goes back to the empirical rule kind of activity we did. And what we know about data that's bell-shaped. And from the empirical rule, there's with all this data, right, this picture here, again, represents, this outline here represents all of the data, 100% of all the data. If it's bell-shaped, most of the data is going to be in the middle. And when I say most, how much? 68% is going to be within one standard deviation from the mean. It's either above or below. And so that's what that means. 95% of all data would be within two standard deviations, either above or below. And this is the magic of the empirical rule and normal or bell-shaped data. It always kind of follows this pattern. And so with that, now we can answer questions looking at some of these problems here. We can now answer some of these questions. And the answers are in here, but I want to make sure you can see that from a diagram. What are we looking at here? So so the way we represent this information is, I want to draw the normal curve. I know the mean in this problem is 330, right? And so we start off with something like that there. And so that's where the mean would be, right here in the middle. And then we know the standard deviation is 45. And so we like to mark off those standard deviations. And again, what that means is I now know the distribution. I now know the distribution of these organs. And so what we know is that the peak is going to be here, start to curve. And so, excuse me for the bad drawing, but the data is bell-shaped. And so then we know that the mean is here right in the middle. And then with those values here, one standard deviation would be 375. Here at another 45 grams, so that would be 25 plus 20, so this is 420 and 465. Coming back down the other way below, if we went below, we then know down here is subtract 45, so this is 285, 240, and 195. So this is the distribution of the weights of these male organs that we're talking about. Again, this came from because the standard deviation was 45, and so you have that there. And so then we can answer these questions based off of this diagram here, the empirical rule here. So this is one standard deviation, two, one standard deviation, two, and above. And so we can answer those questions. You can see the answers here. How many are between 285 and 375? So that's one standard deviation. That's why the answer is 68%, one standard deviation. What percentage weigh less than 285? So here's 285, weigh less, and then more than 375. So we're looking on this side over here. So that becomes 32% because in between these two is 68%. So the leftover 68 is 32. You could also say just add these values up here. That turns out to be 16% and 16% because this is less than 1 standard deviation, more than 1 standard deviation on this side, more than 1 standard deviation. So what this really question is asking is what percentage are more than 1 standard deviation away from the mean. So we're looking on this side. And so we're looking on this side of 375 and 285. And then what percentage of organs weigh between 285 and 465? So on this question here, let me highlight that. On this question here, we're talking between 285 here. So I want all the organs between 285 here. And we're going to 465, which is over here. So this is these are the number of organs I'm looking for, I'm interested in. And so what I have to think about here is that here, that's 1 standard deviation. Here's 1, 2, 3 here. So that's 3 standard deviations. And so what we're going to do is you're going to add up those values over here. You have 34% for 1 standard deviation. So in this case here, we're going to end up doing 34% plus, and then you have from the mean, we have from the mean all the way out over here. And so that's 34 plus 13.5 plus 2.35. So there's your 15 right here, 34, 13.5. And so I'll write it all out there. 13.5% plus the 2.35%. And then we have to add that little leftover part, which is the, oh no, I got the 2.35 and 13. So that would be everything. Oh, I need one more 34. So it was 34, 34, and then those two. So we need another 34 that I forgot. And so in that case, we're looking at 68, 70, 73. And so in this case, it should be 73.85%. That would be our answer. So that's how you do it. So make sure you know the empirical rule, and that's how you manage it.